right, this is APBC Calculus. We're doing midterm review, and this is multiple choice 17, which is a calculator question, although this is one that the calculator is mostly just helpful for the simple addition. All right, so we're given a data about acceleration of a car from 0 to 6 seconds, and we are told that v of 0 is 11, right? So we're given this information about acceleration, right? So this is acceleration, which for the record is v prime of t. We are told that v of 0 rather is an 11, and we're told that we want v of 6, question mark, right? That's what we want. This is definitely a first fundamental theorem of calculus question. The reason I say that is if we integrate what we're given, v prime of t, because that's what acceleration is, from 0 to 6, that's going to be v of 6, which is very much the thing that I was asked to find, minus v of 0, which is a given quantity. So the actual value of v of 6 would be adding the v of 0 to the other side plus this integral. Like this would be the actual value of v of 6, right? But what we're told in this problem is we're asked to use a left Riemann sum or an Lram approximation. So I'm supposed to use Lram to approximate this. And I already know that this is an 11. So I'm going to do Lram plus whatever my approximation is. Now, an interesting side note here, again, someone who's been teaching calculus for like 2 decades, I love to try and spot the traps that the AP gives me. A lot of people are going to forget to add 11 to their Lram approximation answer, like a lot of people. So when I look at the answer choices, I realize that since 30 is 11 less than 41, 30 is probably a trap answer, because 30 is possibly one of the things you might get if you do your Lram approximation, but if you forget to add the 11, you'd miss out on that 41. Similarly, 26 is 11 smaller than 37, so this is also possibly a trap, meaning that if I get 26 and forget to add 11, I might not get the right answer. So just putting it out there that like very often they're smart and they know the mistakes you're commonly going to make and they lay those traps. So now let's talk about this Lram approximation. Lram is just boxes, right? This is literally just boxes that have a base and a height. The base width is going to be the width between the two x's, right? Which in this case, they're all 2. You can see that, right? So 0 to 2, base of 2. The height is going to be the left y value because they said left ram. So on the first interval from 0 to 2, I use the left y value. That's my first height. On the second interval from 2 to 4, I use my left y value. That's my second height. And on the third interval from 4 to 6, I use my left y value. That's my third height. I never use the right endpoint because it's called Lram. So my v of 6 is going to be approximately, I don't want to forget that 11, right, plus, well, the first box has a width of 2 and a height of 5, so 2 times 5. The second box also has a width of 2, but the height is 2. And the last box still has a width of 2, right, because 4 to 6 is a 2, but has a height of 8. So now I just need to add those numbers together. And you could definitely put it in the calculator if your brain is like too fried and just totally over it. If I add all of these together, I get a 30, right? And remember, I have this 11 sitting in front. I intentionally did this first without the 11 because I wanted to point out to you that 30 is definitely a trap answer, because if you forget the plus 11, you get 30. The answer is that this is approximately a 41, and the answer is E, but 30 is a trap. If I were guessing, my suggestion is that there's a good chance that answer A is what happens if you do Rram instead of Lram, and that thus answer C is what happens if you do Rram but you remember the 11, and A is if you do Rram and forget the 11. That would be my guess. So answer is E.